Okay, I'm live. Okay. Hopefully my audio is working now and my screen isn't as laggy like last time. But hey, welcome to the stream. I'm going to be doing Leetcode to prepare for my upcoming interviews. I'm going to share my screen and then begin talking more. This is my Leetcode profile. I've done 464 problems, but I haven't been doing any in the past year or the past like 10 months or so. As you can see, I began doing Leetcode again on September 11, and today is September 16. So I just started 5 days ago. Started again 5 days ago, and I want to prepare for my upcoming interviews. So I'm just gonna be doing this every day. Hopefully, just be streaming, interviewing, trying to solve problems out loud, and I'm just gonna document my whole process with this interviewing season. All right, I will be doing some meta problems. Why not? I just did k closest points to origin, but I realized my microphone wasn't working. So now that I fixed it, let's get started. Let's do, since we just did this one, why not just go to do this one? Kth largest points, largest element in an array. I'm gonna reset my timer and reset my code, and I will be coding in Java. Okay, let's start. Interview mode. Okay, so I'm given an integer array nums right here and an integer k, and I will need to return the kth largest element in the array. And I need to note that the kth largest element in the sorted order and not the distinct element. So I guess in nums, we will be given duplicate elements too. And then can I solve it without sorting? Okay. So the naive solution here is to just sort this, like it will just become 1 2 3 4 5 6, and then return uh, k minus 2. I mean, the length of the array minus 2. So the length of the array here is what, 6, and then we need to return the second largest element. So it would be the index of 4. So 6 minus 2 is 4. So 0 1 2 3 4 after we sort this, of course. But that's the naive way of sorting, which takes n log of n time. And I'm just gonna implement that, I guess. So arrays sort nums, and then I'm just gonna return nums at the index of k nums dot length minus 2. Run the code, and we get a wrong element, so it would be nums minus 1 minus, oh, this should be k. You see, this is how rusty I am. But yeah, this is the solution with sorting, and the time complexity is O(n) log of n, and it's using Java's built-in sorting. And the second approach to this problem is I will be using a priority queue. And since we are trying to return the kth largest element in an array, I believe it would be better to use a minimum heap. And the reason why we want to use a minimum heap is we want to keep this minimum heap of size of k, so that whenever the heap goes over the size of k, we just need to pop from the heap. So by the end, the heap will still be size of k, and what will be in the heap will be the elements that don't get popped. And what elements do not get popped in a min heap? Bigger elements. So by the time we have finished processing this array, the remaining k largest elements are in our min heap, and we just need to return whatever is at the top of our heap, and that will be the kth largest element that we're looking for. This might sound confusing, so I'm going to walk through an example for you guys. So let's say here, this one, and k is equals to 2. So we have our min heap of size k, which is 2, right here. And then we just need to walk through this, and everything will start to make sense. So at the beginning, our pointer is at 3, and the min heap is the size is less than 2, so we can just simply add 3. And then the next one of size 2, we add 2, and this is the top of the heap right here, 2. And then we move on to the next one. 1, we add 1 to the heap. We now see that the heap is of size 3, which is greater than 2. So we pop whatever is at the top of the minimum heap. So we pop 1. As you can see, the two largest elements are still in the heap so far, between 3, 2, and 1. So that's why we're using a min heap instead of a max heap. And then we move on to the next element, which is 5. We add 5 to the heap. And, we see that 5 should be at the bottom of the heap. So 5 goes here. And now we see that, again, the heap is no longer of size 2. So we pop whatever is at the top of the heap, which is the minimum element. So we pop 2. So as you can see, we've done 3, 2, 1, and 5. And what is in our heap currently is the two biggest elements. And then we move on to the next one, which is 6. We add 6 to the heap, but 6 should be at the bottom. So 6 is here. We again see that the heap is greater than size of 2. So we pop from the top, which is 5. And then we move on to the next element and the final element, which is 4 right here. And we see again that the heap is greater than 2. So we need to pop the top of the heap, which is 4. And by the time we reach the end of the array, we can see that 6 and 5 are the two biggest elements in here from 1, 2, 3, 4, 5, 6. And we need to return the second, k is 2, so second biggest element, which is 5 at the top of the heap. So we just pop that and we just return 5. Before I implement this, the interviewer would probably ask for the time complexity. So I'm going to go ahead and state the time complexity of this problem. So as you can see, we have to traverse through our array one time. So it would be n, where n is the size of the array. And then our min heap, whenever we add an element to the min heap, it would be a log of k time complexity because our heap is of size k equals to 2. So our heap is of size of k. So whenever we do this n time, we add the element to the heap n number of times, and each time takes log of k. So the time complexity is O of n log of k. Space complexity, well, we are keeping our heap of size of k, so it's I believe it's just k for the space because we're keeping our heap to be size of k and we're not creating any additional data structures. Okay, so now that I've explained the solution, I'm going to go ahead and code up my solution. So heap in Java is a priority queue of type integer. Call it min heap is a new priority queue of type integer, just like that. And it's a min heap, so it's the default type of priority queue. I don't need to do anything here, syntax wise. Okay, so next one, like I said, go through the number array. So for int n in nums, okay, first thing we always want to do is add it to our min heap. So min heap add n, and then we just need to check to see if the min heap is still of size k or not. So if min heap size is now greater than k, then we need to remove the smallest element at the top of the heap. So we just do a min heap pull. And at the end, we know that our min heap will have a size k, and whatever is on top of that heap is our answer. So we just need to return min heap pop or min heap pull, I believe. Run the code, accepted, submit the code. Okay, first problem done. Pretty simple. 7 minutes and a half to explain the sorting solution and the more optimal solution of n log k using our priority queue. And since this is a priority queue problem, I'm guessing the interviewer would ask me how a priority queue works. So you can just think of it as like a binary search tree. So there's a left subtree and a right subtree, and there's a root node, which is the top of the heap. And whenever we add an element to this queue, our subtree will be created. Go to the left if the element is smaller than the root, then go to the right. And yeah, that's how basically the priority queue works. Underlying is a binary search tree. And this problem is done. All right. Hopefully my stream is still working. Don't have any viewers, but it's fine. No problem. Fixing my screen again. And I'm gonna refresh this page. As you can see, I just did another problem. I'm gonna do a merge problem now. Let's do merge sorted arrays and merge intervals. Okay. Refresh. Okay. Merge sorted array. We're given two integer arrays, nums1. Well, let me refresh and start my timer. Okay. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Okay. So nums1, this is the size of nums1, and nums2, and this is the size of nums2. Okay. The final sorted array, we need to merge the two arrays together into a single array sorted in non-decreasing order, so in an increasing order. And the final sorted array should not be returned by the function, but instead be stored inside nums1. To accommodate this, nums1 has a length of n plus n already. Okay? Where m elements denote the elements that should be merged, and the last n elements are set to n and should be ignored. Okay? So the first m elements are part of nums1. Okay, and the last n elements are set to 0. Okay, and nums2 has a length of n. Okay, let's walk through an example here. So nums1 is 1, 2, 3. Okay, so that's why m is 3, because only the first three elements are valid. Nums2 is 2, 5, 6, and n is equals to 3. And then the sorted is 1, 2, 2, 3, 5, 6, and the arrays we are merging are 1, 2, 3. Yep, pretty straightforward. Naive solution would just be to add nums2 to the end of nums1 starting from index m, and then just do a array sort. So I'm going to go ahead and implement that solution, which would have a time complexity of O n log of n for sorting. So for int I equals to m, I is less than basically n, m plus n, I plus plus. Okay. Basically, nums1 at index I is equal to basically nums2 at index of, it would be, it wouldn't be I, because it would be just I minus m, because it's m spaces ahead. And then we just do a return arrays sort. Well, we don't need to return anything. So array sort nums1, just like that. Oh, this should be nums1. And yeah, this is the non-optimal solution, n log of n. The next solution, which is this follow-up here, can you come up with an algorithm that runs in O m plus n times? So it should just only check each array one time, totally. And the answer to this is, of course I can, because I've seen this and I've done this problem. But I'm still going to walk through how I would approach it. Okay, so we have nums1, we have m, and then we have nums2, and then we have n. Okay, so we can use two-pointer approach. So in this case, we have nums1 and nums2 right here. Okay, I'm going to walk through an example of how I would approach this. So we have these two. Okay. And what I would do is basically we know that here it's empty and we have the index of where nums1 should be and where nums2 should be. So we're gonna take advantage of this. So I'm gonna tab so I go to here, actually go to here. So we're gonna maintain two pointers, one for nums1 and one for nums2, just like that. And how do we know what these pointers are? We just do a n minus 1, which is 2, so 0, 1, 2, and then n minus 1, which is also at index 2. And then we would need to, we know that these two arrays are sorted in increasing order. So if we go from the right to the left on each side, on each nums array, we know that we can just compare the two current indexes, and whichever is bigger, we just add it to our second pointer, which is at here. So this might not make any sense right now. So let's walk through an example. So we're comparing 3 and 6. We know that 6 is greater than 3, so 6 should be added here. So we add this here to the current pointer, move this pointer to the left by 1, and move the nums2 pointer to the left by 1. And we begin our next comparison. So now we have 3 and we have 5. We know that 5 is bigger, so this has to become 5. And then this pointer goes here, and this pointer goes here. Now we're comparing 3 and 2. We know that 3 is bigger, so we have to make it the current pointer to be 3, and then we move nums1 pointer to the left, as well as this pointer to the left. Let's call it our merge pointer, okay? Now we're comparing 2 and 2. Doesn't matter which one we add. Let's say we add nums1's 2, so this becomes 2, and we move to the left by 1 time. Now we're comparing 1 and 2. This has to become 2, and this pointer moves to the left, and this pointer becomes down here. So we have two overlapping pointer, and we see that 1, we're not comparing to anything, so we need to set this to be 1, and then we move this pointer to the left as well as this pointer to the left, and we have finished processing our work. So this solution makes sense, O of m plus n, because we're only going through nums1 one time and nums2 one time. So it's O of the size of the first array actually, plus, so it's O of m plus n right here. That is our solution. Okay, so I'm going to go ahead and implement it. So we need the two pointers as discussed. So call it index 1 is equal to m minus 1, and index 2 is equal to n minus 1. And then we have an index of index merge. So im is equal to basically m plus n minus 1. Okay. So how do you know when to exit? We need to make sure to that I1 and I2 becomes 0. So we have processed every elements in nums1 and nums2 from right to left. So we need to do a while I1 is greater than or equals to 0, and I2 is greater than or equals to 0. So we need to add an OR here because we don't want to exit once the first one or the second one reaches 0. So this should be greater than or equal, just like that. All right, we have these I1 and I2, and then we need to see if they are both, if we can still process and compare both arrays to each other. So if I1, I can just copy this clause right here. Then we need to compare. Otherwise, else if I1 is greater than or equals to 0. And then else, this would be the case where only I2 hasn't been finished processing. So only nums2 hasn't finished. Okay, so now we need to do a comparison right here. So if nums1 at I1 is greater than or equals to nums2 at index 2. Yep. Then we need to add for nums1 at the merge index, or index merge, is equal to nums1 at I1, just like that. And then we need to decrement IM minus minus, and also decrement index 1 minus minus. Else we need to do, I'm just gonna copy this and change index 1 and nums1 to index 2 and nums2. Well, nums1 should still be here. This should be nums2 at index 2. Okay, and then I2 minus minus, just like that. All right. Well, this should be an AND. If both can still be compared to each other. And then here, this would be the case where we have finished merging nums2, but we still need to process nums1. Then we can just do a nums1 at I1, well, at the merge index, is equal to basically nums1 at index 1, and then you can just copy this. Similarly, if there's only elements in nums2, then you process nums2 at index 2, and this becomes that. And this would be my entire solution. Let me minimize this so you guys can see the code. And I'm gonna walk through, I guess, my quick example then, my own example, to prove to you guys that this still works. So let's just say we have 1, 2, and m is equal to 2. And then we have 2, 5, 6, and n is equals to 3. So the size here should be 5, so 0, 0, and 0. Okay. So we begin here. Index 1 is at m minus 1. So index 1 is at 2 minus 1, which is 1. And then index 2 is at n minus 1. So index 2 is right here. Okay. And then this, I'm going to say this is IM. Okay. This is I1, and this is I2. Okay. Let's walk through this example. And IM is right here. Okay. Okay, so now we are going in the for loop, the while loop actually. So we see that both indexes are greater than or equals to 0. And both, so we go into this if statement, and then we're comparing basically 2 and 6. We see that 2 is not greater than or equals to 6. So we set here nums1 should be equals to 6. So this becomes 6. And then I minus index merge, and index 2 gets decremented. So decremented. The for loop is still working because both are greater than 0. So now we are comparing 2 and 5. As you can see, 5 is bigger. So we go into this else statement again. This becomes 5. This gets decremented, and this gets decremented. Okay, so now again, they're both greater than or equals to 0. So we go into this if statement, and now we're comparing 2 and 2. As you can see, 2 is greater than or equals to 2. So we can go into this if statement. And so we set here becomes 2. And this goes here for index 1. This goes here. Okay. Next run, as you can see, 2 is greater than 1. So we go to this else statement. And then we set this to be equal to 2. We decrement this pointer, and we decrement this pointer. So now we see that the index 2 is -1. So this becomes false, but this is an OR statement. So we still go into the loop because this is still true. However, we don't go into this if statement. We go into this one because I1 is still greater than or equals to 0. And we set this to be itself, decrement, and decrement, as you can see here. So now in the next iteration, we see that both of these conditions are false, and we have finished, and our array is sorted 1, 2, 2, 5, 6. I'm gonna run this, and I'm gonna submit. All right, perfect. Time complexity, as I said, is n plus n plus n, because we are going through this array of size n plus n one time, as well as this array of size n. All right, solve this problem. Delete, refresh. I'm still streaming. No viewers, but it's fine. This is just me practicing coding out loud. Meta man, you guys gotta hire me. So 6 out of 90. Making progress. Let's see if we can get to 10 today before the end of this stream. All right, next problem. Refresh my timer. Let me take a quick drink break, and then we'll get straight into it. Okay, let's resume our session. Merge intervals. We are given an array of intervals where intervals I, index I contains a start and an end coordinate. We need to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all intervals in the input. Okay. Let's walk through an example: 1, 3, and 2, 6, 8, 10, and 15, 18. So I guess we need to compare the current interval with the next interval right here and see if there's any overlap. Merge them together, and then compare this merge interval with the next interval to see if there's any overlap. Find a merge if there's an overlap or not. Switch to this interval, and then compare this current interval with the next interval and repeat the same behavior. Okay, so I'm gonna walk through this example. Okay, so there is an overlap if the end of the previous interval is the same as the beginning of the current interval. Okay, cool. So I'm gonna walk through this example. We have 1, 3, and 2, 6, and we have our current. I hate that period thing, bro. All right, so we have 1, 3 as our current interval. So currently, and we need to compare it with the next interval, which is 2, 6. And this is our answer array right here. We see that 1, 3, and 2, 6 overlap, so we merge them into 1, 6. And then now we move on to the next interval, which is here. However, we have already merged this interval, okay? So now we move on to the next one, which is comparing 1, 6 and 8, 16. We see that there's no overlap, so we add basically 8, 16, and this is 8, 10, sorry. And then we move on to the next one. Well, we check with the next one actually. So 15, 18 does not overlap, so we move on and we process this one. So we do a 15, 18. Okay, so what's the logic here? Let's see. I guess I will begin at the second index and compare the current interval with the previous interval, and then move on, compare the current interval with the previous interval, and then move on, compare the current interval with the previous interval. Okay? So let me walk this again from the beginning to see my logic. So we have 2, 6, and we're comparing to 1, 3. We see that there's an overlap, so we merge them. I guess we can have a variable called previous interval, which is initially set to intervals at index 0. Okay? And then this is basically current interval right here. Okay? So 2, 6, comparing it to 1, 3 for the previous. we see that there's a overlap, so we merge it into 1 6, and then we set previous interval to be 1 6 before we move on. So when we move on, we're 810, we're comparing 1 6 to 810, there's no overlap. So before we move on, we have to set previous interval to be 810, which is here. Okay, say we have another interval here that is, let's see, 9 12. We see that when we move to 912, we see that there is an overlapping with the previous interval. So this has to become 812. And then we move on to the next. So we need to add 812. Well, not yet. Let's just say we're at 1 6 and we're at 812, just like that. Okay, we move on to the next one, comparing 812 to 1518. There's no overlap, so this is when you add 812 right here to here. And now previous interval becomes 1518. And then we move on. We see that we are out of bounds, so we just need to add the last previous interval right here, and we have our answer. Okay, the time complexity of this would be O of n, where n is the length of intervals, also known as the number of intervals in this array. Okay, like I said, I'm going to begin my solution. So int previous interval is equal to a new int. Well, we can just set that to intervals at index of 0 since we're beginning at 1. Okay. And then we just have our for loop. So for int I is equal to 1, I is less than intervals length I plus plus. And then we need a list to store all our non-overlapping intervals. So list, call it IL for interval list. It's a new array list, just like that. Okay, let's get the current interval. So int current interval is equal to intervals at index I. Okay. Now we need to check if there's an overlapping. How do we check if there's an overlapping? If the previous interval ending, so if previous interval index 1 is greater than or equal to the current interval at index 0, then there is an overlap. Then we need to merge previous interval. So previous interval index 0 will become the minimum between the current and the previous. So in this case, right, our interval should be 1 6. So we need to compare the minimum of this one and this one. So math min between previous interval at index 0 and current interval at index 0. And then the ending of the previous interval, previous int 1 would be equals to the max at the ending. So this would become max and this would become 1 and 1, just like that. Else, if there is no overlap, and we know that we don't need to compare the beginning because we know that this interval array is sorted. Okay, is it sorted? Oh, okay, we forgot one part. So if the array is not sorted, we need to sort it. So array sort, basically intervals by comparing a, what's the syntax for sorting, but we're comparing only the beginning. So we want to sort it by beginning. So 1, 2, 8, 9, 15 in this case. Array sort interval A comparing to B. Then we just need to do A0 minus B0, just like that. Because if A comes before B, it will be a negative number and we just sort it. Okay, so we have sorted our intervals by beginning, so we don't need to worry about comparing the beginning here. Otherwise, There is no overlap. So this is the case where there's an overlap. Otherwise, we there's no overlap. Then we do a uh, interval list, add the previous interval, and then now the previous interval will becomes the current interval. So in the case where there's no overlap, like right here 9 12 and 12 15 18, then this line will add here. Well, this would become 8 12 actually because of the merge. So in the case where there's no overlap in endpoints, this would be added, and the previous interval would become 15 18. So when we exit out of this, we want to make sure the last interval gets added. So IL add previous interval, just like that. And now we have our list to return. We got to convert it to a 2D array. So we need to do a return. How do I convert this to a 2D array? Chat GPT time. I need to review my syntax. Convert this to a 2D int array in Java. Without using a for loop, ChatGPT. Convert using a built-in function. IL to array, and then you need to give it a size. Okay. Back to our problem. Return basically. Let's see. IL to array. Is it to array or to arrays? To array. A new int array of size IL size, and boom. Cool. Accepted. Submit. What would be the time complexity of this problem, you might ask? Well, first, if the array input, if the interval input is not sorted, this would be n log of n. Plus, we need to traverse and traverse and eliminate overlap. So it's O of n. So it's O of n log n plus n. And the space complexity for this is, let's see. So let me write the time complexity. TC is O of n log n. And space complexity is O of, let's see, not n log n. I'm just blanking out. Sorry. Space complexity, because it's just O of n, because we're making this list. Or O of 1 if we don't count this. Because this list is only being used to store our result. But yeah, that's the time and space complexity. Cool. I'm very close to the screen again. There's 2 people watching. Okay. How do I see who's watching? Participants? Oh, it's only me? There's 3 people now? What? How do I see who's watching my stream? But yeah, we've solved another problem. Let's refresh my list right now. It should become 7 out of 90. Okay. 3 people watching. Who is watching? How do I see who's watching my stream? Anyways, next problem. Let's see. Which one should I do? I want to do another interval problem since we're already doing interval stuff. So interval. I think I did one recently and I want to go over it again. So how do I threesome? Add two numbers. I want to see. Let's do add two numbers. All right, it's been a while. I've done this, but haven't done it in a long time. Yeah, last time I did it was over a year ago, and I've done this a fuck ton of times. All right, reset my timer, and I'm going to start it. Read the problem again. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. Okay. So here we're adding 342 plus 465, right? Because the list is in reverse order, which should become 2 plus 5 is 7, 4 plus 6 is 10. So we put 0 here, carry over 1. So 3 plus 4 plus 1 is 8. That makes sense. And then we can return our list in reverse order too, which is nice. Okay, well, the solution here is pretty simple. I mean, you just need to write code that simulate adding. We need to one pointer at 2 and one pointer at 5. So at the beginning of each list, and we just need to go through every single node, keep track of the carryover, and then we know that we're at the very end when we are at, what's the word for it, when both lists are null, like when both pointers here are null. There's a case where it's like this one, right? 99999 plus this one. Then we know that L2 will reach the end at index 3. So once we're here, we need to just keep going for L1, but don't take into account L2 because that will result in a index out of bound or a no pointer exception. So like I said, we need to keep track of a carryover and keep track of L1 and L2. And we can just make a list node to return at the very end. So result list. So RL for result list is a new list node. Well, let's just set it to, yeah, new list node of size, basically, yeah. And then we need a pointer to know where we are in this result list. So result pointer, yeah, RP is equal to result list. Because at the very end, we want to return this, whatever comes next. Okay, so now we go into our loop. So while L1 doesn't equal to null, or L2 doesn't equal to null, and we're using or because of this case right here, right? We want to keep going until both pointers are null. Okay, we just got to check int carry over. We want to set carry over out here too. Int carry is equal to 0. Okay, so now we need to basically check if L1 doesn't equal to null and L2 doesn't equal to null, then we need to add both of them. So int current sum is equal to 0. Then we do a current sum. I can separate this out to be more efficient. So current sum would be plus equal to 0, and then we just set it to the carry. Okay, current sum plus equal to L1 val, and similarly for L2 right here, L2 doesn't equal to null, then add that. Now we need to check if there's a carryover. So if current sum is greater than or equals to 10, then current sum would be equal to basically whatever current sum is minus 10. So current sum minus 10. And then we need a carry, and it would just become 1 in this case because it's guaranteed to us that each node will contain one digit as the value. Okay, carry is 1 right here. And if there's no carry, then we need to reset carry. Else, we need to reset carry is equal to 0. And then once we're at the very end, I can just do a return. Oh, I need to advance our pointer too, because I forgot to add this as a list node to be returned. Okay, so we can do a result pointer is equal to a is equal to a new list node right here of size, of value. I can just do here dot next is a new list node of size current sum, and then result pointer is result pointer next, and at the end I just need to return our result list because it's still at the beginning. So result list dot next right here, and I believe this solution would work. Let me check if there's any syntax errors. It's a new list node. Yep, I'm using this constructor. Result pointer. Yep, I have carry. Well, both pointers are not null, and we need to add the current sum. And then if current sum is greater than 10, current sum would be minus 10. Yep, and then we need to set the carry. Otherwise, we need to reset the carry. And yeah, this should work. Oh, I'm forgetting to increment my pointer. So L1 plus plus L1 is equal to L1 next, and then L2 is equal to L2 next. Okay, I'm going to run this. We get a wrong answer here. Let's see. Move this out of the way. I'm missing the 1. So here, I just need to check if carry is greater than 0, right? Then we know that we need to do a RP next is equal to a new list node of size carry. And yeah, we can just return. All right, accepted. I missed this one edge case right here. If there's a carryover and it's the very last element, then this loop will exit because after the run, L1 will be null. So when we're here, we move on to the next one. So it's null. However, we still have the carry, which is 1 because we're doing 9 carry over from here. So we need this if statement. And then, yeah, we are done. Done with this problem. I'm going to submit. Cool. Time complexity, like I said, is the size of L1 plus L2, however many nodes there are in L1 plus however many nodes there are in L2. Another problem done. All right, 8 out of 90, making good progress. What do I need to improve on? This one. And yeah, I did this problem, but I'm going to walk through an example so that in an actual interview, I need to be able to. So if we have 2, 4, 3 right here, and 5, 6, 4. Okay, let me walk through this example. Okay, so we have L1, and then we have L2, and then we have basically our result pointer is empty for now. Okay, so we see that both pointers are not null, and current sum is 0. Okay, L1 is not null, so current sum would be 2. And then L2 is not null, so 2 plus 5 is 7. Current sum is not greater than 10, so we need to set next is a new list node. So RP is now size 7, and then the pointer is here, okay? And carry is still 0, okay? So now we need to increment this one and increment this one. That's right here, these two lines. Now we're adding 4 and 6, which is 10 for our current sum. And we move the pointers, right? L2 next, L1 next. So current sum is greater or equal to 10. So current sum is minus 10, so it becomes 0. And carry now is 1. So now we have a value for carry is equal to 1, okay? So then we set whatever this next to basically the current sum, which has been reduced to 0, and then we move the pointer right here. The next one, we see that both of these pointers are not null, so current sum would be plus L1, and now carry is 1. So this line right here, current sum is already 1, okay? So now current sum plus 3 and plus 4 is 8, okay? 8 is not greater than 10, so we reset carry is now 0. And then we set the next one to be 8 in here and move this forward. And then we see that both of these are now out of bounds. So we simply exit and we return the result list next, which is result list is still at the beginning, so you return this one. That's basically it, the walkthrough. All right, good for now. I'm going to end the stream. Did a few problems. I think I did like 4. All right, end stream. Goodbye.